We're on the border. There's no cars.
Yeah, I don't know what they are.
specifically, but you know, we make a rover, go down to Florida, compete with that. We'll go a little more frame. And then specifically for today, we were trying to refocus. Last year, our system requirements review was a bit different, but this year we're really focusing on specifically the NASA guidelines and the team goals, sub-team goals. We'll talk about NASA requirements of our system and our team and how we're going to approach those, what personal team limits we're going to apply so that we can definitely be under the tolerances that NASA provides us. Yeah, and for the itinerary, we'll do pizza, and then we'll talk over basic timeline, point breakdown, competition stuff, general guidelines, and we'll break out into the different sub-teams. Sound good? Okay, pizza in the back, and we'll meet back here in like 15 minutes.
Great. All right, great design review. Now let me get some. Yeah, right. The attendance is taken. How you doing this last night? stories. I just put them there for, I don't know, anyone.
All right, so this is our timeline for the year. Some of these things, especially the later things, are subject to change. Hopefully NASA doesn't change some of these like papers and stuff. But basically, yeah, like we have the guidebook. It's still, you know, version 1 of whatever. So hopefully, there's some stuff that's not fully outlined, but we'll talk about the stuff that is. Project management plan, that's just a paper that we're going to work on.
Do we do, where's the,
Never mind, I'll talk about it. I got it. Yeah, and then we'll do preliminary design review, the PDR, that's October 19th, pretty set on that date. It's just another Saturday, 12 p.m. Hopefully all you guys will be able to go there. Just like this. Mechanical design freeze, we'll talk about mechanical stuff, but I think we're setting a good date for that, a little earlier than last year. Critical design review, it'll be February. Other design reviews. Yeah. Any questions about the timeline? Okay. I think we should. What is Passover? Where's the? I forgot to do introductions. Yeah, there's supposed to be a leadership slide, right? I don't know where it went.
I wasn't there when we worked on it.
I guess so. Maybe I'm thinking about everything. But anyway, I want to introduce, well, I'm Brandon McEwen. I'm the project manager, and helping me out this year is Aiden Randall, assistant project manager. We've got, yeah, stand up. Say hello.
And then I'm Callie Lewis, I'm the president this year. Then we got.
And I'm Faith. I'm running this production. So if there's anything wrong, let me know. I'm the vice president. I think I said that.
All right, and then we'll do.
John and Ben.
Yeah.
do I want to come up to the front?
If you want to.
Do I need to?
Yeah. Okay, John Treasurer. We got
I'm Garen, and I'm the marketing officer.
And then you'll meet our managers and most of our leads throughout the presentation,
Yeah,
so they can probably just introduce themselves then.
Thanks. And yeah, we got competition point breakdown. If anyone wants to present this one.
Sure. So these are the these are the main things that NASA will grade us on for the competition. Everything here is important, but I want to emphasize that the systems engineering paper is basically the same as the robot in terms of points, so it's really important to work on that and get that done. Yeah, because the next slide, the robot, we'll go in depth on robot construction about what the point breakdown for that is.
It's interesting. So many of our points come from just the organization through different documents, different essays, basically. Definitely, you know, the robot's important, but the means of how we get that robot working, that's what matters. Hopefully, trying to put a good emphasis on project management this year, trying to do some more documentation, do some of these papers better. But yeah, hopefully we'll have a good year with all that. Robot construction point breakdown. Basically, I don't know, do you want to present this one? Sure. John has a good way of explaining this one. It's interesting how they do the different percentage breakdowns for this point.
Yeah. So this year, NASA will be changing the way that they actually do the scoring at competition. So like the graph, the approximate weight is kind of just the number that they give. There is a different point value per each one of those categories. So they're going to be using a cumulative normal score. So pretty much it's going to be more important that you dig as much as you weigh, if not more. So we have a normalized score based on berm volume and mass. And we also have berm volume per watt hour. So there's also the big change, which is we are getting a direct ratio between volume and our watt hour consumption. So that is a lot bigger of a change than just a straight up subtraction from our total points like last year. There's also the dust proofing points are worth more this year at competition. So I think it went up 10 points, but there is pretty much no reason we shouldn't get full credit this year. And then autonomy, that will be a really deciding factor of competition this year. So keep in mind that these 600 points is going to be worth more than anybody will dig. It doesn't matter what size you are. So we have the potential to double our digging points off of autonomy. That's all I have.
Thanks, Ron. General competition guidelines. So overall, arena is pretty much the same. This is actually, this is the same photo from the guidebook last year. Is this specifically Kate?
This is the NASA place.
Yeah.
Okay. Yeah, Kenny space. But overall, berm requirements, it's going to be 2 meters by 0.7 meters, just right there. All the dimensions are the same. Max volume, same. Max volume for the robot, I should say, and max height, max mass, 80 kilograms. We're going into detail about how we want to do a mass breakdown, kind of. And just like a kill switch, some safety things. Still constructing a berm just like last year. Any questions? We can do outreach.
So the past couple of years, we haven't reached these outreach requirements. We just got our scores back for this past year, and we did subpar, but that's okay, we tried. So what we're doing, we're revamping our outreach efforts to actually correspond with what NASA requires us to do. So they require direct education engagement and indirect education engagement. And those are there. So specific events focus on teaching programming and computer science skills and focus specifically on the Artemis mission. And then indirect, focusing on teaching about one of the following: NASA Artemis, in-situ resource utilization, lunar regolith, STEM careers, way for students to get involved in NASA with their high school programs, the space museums and stuff that you can go to, those sort of things. So it's actually not in this year's guidebook. They did not release anything regarding any paper except for the project management plan. So this is all based off of last year's guidebook. So hopefully it does not change very much. So to meet those, we have our direct and our indirect. So our direct engagements is with Sphere robots that are on their way now. What we're going to be doing is we're holding an event. That's on the next slide, is all the events we're having. We're going to the Akron Public Library, and we have an event set up. We're going to have 30 students from grades 2 through 5. They're going to come in, and we're going to work with them, and we're going to program a Sphere robot to get through an obstacle course. Mechanical engineers on the team are designing those obstacles right now. My software guys are going to help me with the presentation and help me with the coding once I actually get them in and we can look at it. It's block coding, so it won't be too challenging for the kids. And then we have our indirect lessons. We have lunar life lessons, where the students are going to learn about using the resources on the moon once we get there, and spend time creating their own little lunar rover. So an example of that's the one down at the bottom there. That's an actual image from NASA. So it's going to be slightly different. We have all these fun little supplies. We're going to bring sand, and then they'll get to ride them through. And then our space exploration lesson, which is our very short lesson for events like Kids Career Day, if you've ever helped out with that before. A lot of you will get to this year, so it's actually going to be really fun. What we're going to do is we're going to be soldering PCBs with them. Any of the alum, we're going to back the badges. So all the badges, I'm working on those. I'm working on getting an updated, the list of everything that goes on those, because everything was not stored together, so I need to find everything. But we are working on that, and then we have other electrical members working on new PCBs to be able to have that with the students. And then these are the events. So Saturday, October 5th is the Akron Public Library. November 2nd is the Firestone events. This doesn't meet requirements, but we are teamed up with them, Firestone High School, and we go to their VEX events. It's a really great day, really fun. You get to, talk to all the students about their designs, what they're doing. We have the lunar surface lesson. We're teaching at Serve Akron's Swag Kickback. That's students with a goal. And then February 22nd, we have another VEX event. I'm working on a couple events right now that are not on here yet because I don't have a date. Kids Career Day is going to happen in the spring. Goodyear STEM Day is in the spring. Serve Akron Youth Mentorship, I'm working with them right now. And I'm working with the local Girl Scout group. So we might have them coming in. We'll either do it at Express or we'll rent out a room here. But that's all I have for outreach. Any questions for me? So, thanks, guys.
Another outreach thing that I do, if anyone's interested, I help out the high school, Madison High School, and they have just an all-girls combat robotics team, and it's pretty fun. This year they actually, in the past they've only had like 4 girls on the team, so it helps they'll like do up a little CAD design and I'll look over it, edit it. But this year they have 10 girls, and a lot of them are getting new, they're not very used to CAD at all. So if anyone wants to help out with that, they accept any sort of advice, and we just do meetings, so let me know if you're interested.
You have time and what days?
Usually it's Wednesday evenings. Yeah.
Is it
I don't
still
know.
virtual?
Yeah, it's still virtual. You can go in if you want, but yeah.
Pretty easy opportunity since it's virtual.
Yeah, that's good. Or I could just add you to the group meeting, because a lot of stuff is on the mechanical.
Hi, I'm Nick. I'm the mechanical manager for this year. You all can hear me, right?
Yes.
All right. So some of the requirements we're sending forth is a mechanical sub-team. Revolve around weight and size, because we took a beating for the weight of a robot last year in terms of points. The maximum competition allows is 80 kilograms. We weigh about 89.5. We lose about 8 points, under the previous scoring system, we lost about 8 points per kilogram of robot mass, which comes out to about minus 630, 40 points, somewhere around that. This year, we're aiming for, we still have the same maximum, but our limit that we are setting ourselves is going to be 40 kilograms. We're looking at half that. The way they're scoring robot mass this year is cubic centimeters of excavated burn volume divided by robot mass. So what that means is that how the math works out is if we scale our robot upwards, keep the same design, it won't change our points because we are increasing our bucket capacity by that same amount and holding that same amount. But our weight is also going up by that same factor. So we need to go for a density efficient design and be able to make every kilogram of robot count. For our size, we have the limit from competition of 1.5 meters, that's length, typically length, by 0.75 meters by 0.75 meters. Last year we were about 1.5 meters by 0.75 by 0.74 in height. This year we're looking to shave a few centimeters off just to stay comfortably within that restriction. And we're going for 1.3 meters by 0.65 meters by 0.65 meters. So 1.3 in length, 0.65 in width, and no more than 0.65 in height. So these are our overall goals this year. Again, scoring is volume excavated by robot mass. Total mass no longer matters. Of course, the efficiency of the design. Another goal we're aiming for is modularity. As a team, we'd like to be able to develop subsystems as independently as possible, while still ensuring that they integrate well. The idea behind this is that the lead of each subsystem will be able to work with the members of their system to develop it with their own deadlines and doing their own independent testing. Something that would include is, I actually got this idea from something Brandon did 2 years ago, is a test fixture for excavation. So if we could simulate the robot frame and the attachment points for our excavation system, then we can actually see the full range of motion physically. And also, electrical software will be able to program and test that ahead of time, instead of when it's already on the robot. Another goal, this one's pretty ambitious compared to last year, is we want to have a fully functioning locomotion system designed and built by the end of this semester. That way, software and electrical can wire it up and test it come the spring semester, and we have plenty of testing time to be able to work on locomotion autonomy and get all the quirks ironed out. Thank you.
Hi, my name is Lane Klein. I'm the electrical manager this year. This is
And I'm Eli Bukowski, electrical team project lead.
so we probably should switch sides, but that's okay. So, electrical requirements for this year. Power distribution, we want to obviously provide power to all systems. And as part of that, we want to have a redundant safety power cutoff system just in case something goes wrong with the robot. It's called an E-stop. We're going to have to buy that off the shelf as per NASA requirements. Next, we want to monitor our power usage, as we talked about earlier. We have to actually watch our watt hours kind of closely this year for the robot. So we're going to monitor that with another off-the-shelf like energy monitoring system, and hopefully we'll build a battery that's a reasonable size and B is good with like energy density, and we want to make it reliable, obviously. So we want to use we want to use the right size for components. We don't want to overshoot anything. Don't want to undershoot either, and use vibration resistant connectors so everything stays nice and good, even with robots jumping in holes and jumping out and everything.
And so, in addition to the requirements set by NASA, we have our own goals for the year. These also include modularity, sort of like the mechanical team. We're trying to design discrete modules for certain actions, like a specific PCB to control and drive a wheel, for example, or an actuator. And these will all use a sort of unified communication network so that it ties in well with both the remote station with the operators and the single board computer on the robot. And then another goal we're setting for this year is reusability. We're trying to create an e-box that will be usable year to year as we are able to connect different modules to it.
Everybody, I'm Jackson. I'm one of 2 co-officers for the software team.
Hi, I'm Nathan O'Brien. I'm the other co-officer.
I'm John. I'm a lead. I'm going to be controlling autonomy and leading that.
Yeah. So to get into some of the requirements and goal specifics set by NASA, here are some just a couple of quotes that give you in a nutshell of the competition, but for the specific software requirements, I'm going to do it off the dome. So 2 things that are software specific that not a lot of the other teams have to deal with is sensors, so those camera points. The less cameras that we buy from NASA, the more points we get. Buying a camera, basically, they allow you to view a camera that's in the field. We can apply sensors and cameras on our robot to minimize the point penalty for buying those. So that's something that we can work on specifically. Along with that, autonomy, obviously. We can easily get at least a minimum of 150 points. For that, you just have to do a dig cycle. And then there's other distributions of points for that. So navigating from your starting area to the dig site without touching the keyboard at all. That's a little bit more complicated, but we can definitely get something that'll get us a few points. So we should be able to hit a 30% autonomy goal, at least I would say 50% of that, which is a lot of points. So if you could take it to the next slide for me. So with those requirements in mind, how are we going to achieve that? What goals can we set internally to hit those points? We have a couple of things that we really want to focus on, specifically controls. That is something that we need to have done early on, so we had a system to build off of for autonomy. And all of those other points are dependent on controls, because if you're not doing it autonomously, you have to do it in a way that you can input a command or some joystick movement and it come out reliably and consistently. And to make sure that it is consistent and reliable, we will have some redundant systems. That'll allow us to, if a system shuts down, we can still control it and move forward without having it impede our progress too much. In the past, we haven't had this problem, but again, it's always good to look to the future, which again brings us to two of our points over there, modularity and standardization. Those two goals we set will help us build off for coming years. That's something that we've really hit home. You've heard it from all the other teams. It's something we started last year with our GitHub reorganization, and we're going to plan on continuing with. It not only helps us get a running start at the beginning of a new year, it allows us to better write the system design reviews for NASA. So not only is it good internally, it gets us points, which is always nice. So that is pretty much all of the goals that we have. Anything y'all would like to say before we hand it off to, I believe, who's next? Where's that at? That was it. That was it.
So yeah, pretty short and quick today.
Yeah.
So yeah, now we can just open discussion. If anyone wants to say anything for the good of the group. Anything? No.
Any questions?
Comments, concerns?
Concerns?
All right. Well, thank you guys for listening.
And feel free to grab more cakes and everything.
Yeah.
Don't tell me, Dwayne. That was pretty cool.
That was a lot bigger than the one that we had last year. Remember last year we had like an hour and like